The subject of study is lateral shift. In the previous session, we dealt with normal shift. In this session, let us deal with lateral shift. Lateral shift, it happens when the light passes from one medium into the same medium but through another medium. In this setup, we have a glass slab surrounded by air. This is the denser medium. This side we have rarer medium and the same rarer medium. The object is kept at one side of the slab and we are leaving the object on the other side of the slab in this direction. What would be the change in the ray of light if the light is passing from this point to this point? This is a point of object, this is a point of view. Let us take a ray of light from the object. It is coming from the surface of the object as a result of reflection. This is the ray of light, this direction. And at this, there is a interface. At this point of interface, the light undergoes refraction. There is a refraction of light. The refracted ray deviated towards the normal. What would be the normal at this point? This line is called as normal to this at the point of incidence, straight line parallel to the interface. So it is deviated towards the normal. This is known as angle of refraction, this is known as angle of incidence. It is always less than this. And until then it is straight line, the refracted ray in the denser medium. And again at this point of interface undergoes one more refraction. So the refraction is what is the deviated away from the normal. So this is the normal. What is the normal at this point? The straight line is the normal at this point, deviated away from the normal, because light is passing from the denser to rarer medium. Here the deviated towards the normal, since it is passing from a rarer to denser medium. Difference. This is how a ray of light undergoes a change. There are two refractions at 2 points. Refraction at 2 points. The resultant is called an emergent ray. That is, this angle is same as I, this angle is I. Incidence ray, emergent angle. Emergent ray, incident ray, angles are same. In viewer's view, how does it look? This line, what is that? This line of ray changes into this line of ray due to refraction through this. Refraction at 2 places. Look at the ray. Then how does the object look like? In viewer's view, how does it look like? The object is here, but it appears as if the object is kept here. It is the image of the object. This image is virtual image of the object. How do we get it? In this direction it is weaving, so it should be a straight line in the backward direction. We get it by drawing dotted lines in the backward direction, this would be the position of the object. Looks like image formation. In this case, this is a line, straight line, this is a straight line. Difference here, viewer is observing the object in this line, in this direction, along this line. This is the image he is observing. This is a straight line. This would be the line of ray if the glass slab was not kept over there. This would be the line of ray if this glass slab was not kept over there. Because of the glass slab, it has changed the line into this line. So it is a direction, is a image formation. It is known as lateral shift. Why it is called as lateral shift? This line is shifted sideways in parallel. The difference here, this line and this line remains in parallel. No difference, but direction remains same. Remains parallel but shifted sideways. It is also called as lateral shifting. That is shifted sideways, lateral shifting. The distance of separation is called as lateral shift. The distance of separation. The distance of separation between the two parallel lines is a perpendicular distance. This distance is called as lateral shift. So it is known as lateral shift. And here the object is kept along the horizontal line with respect to slab, and it appears to be shifted. It appears to be shifted from this position to this position along the line. It is called as horizontal line. It is horizontal shifting. The other way is called as horizontal shift. This way is called as lateral shift. But actual distance is the distance of separation between the parallel line. It is the perpendicular distance. It is called as lateral shift. Due to this lateral shift, the object appears to be present here. It is another way of optical illusion, but you are not calling it as optical illusion. We are calling this as parallax error. What is parallax error? Parallax error is when the object is weaving in certain angle, not straight. When it is weaving in a certain angle like this, there is always a error in the measurement of position. It is called as parallax error. That parallax error is magnified. That error is magnified because of the presence of glass slab refraction. So it is a parallax error. The difference, this would be the position. The position is looking like this. The difference is called as parallax error measurement. So it is known as lateral shift or horizontal shift. The meaning, the concept, that concept is called as lateral shift. This is a phenomenon. The lateral shift means shifting of light ray sideways due to this glass slab is called as lateral shift. This distance of separation or lateral shift can be in the form of equation. It can be in the form of equation. So that equation is always a function of thickness of the glass. This is the thickness of the glass and the angle of incidence. This is the angle of incidence. Lateral shift, the distance of separation. depends on these factors. Let us see how can you derive this equation and what equation you get after the derivation, lateral shift function. For the derivation, let us look the geometry in details. The geometry of what is the domain, the drawings of this geometry in details. In addition to that, let us make some geometrical drawings. This is what the ray, incident ray, refracted ray, and emergent ray. This is the angle of incidence, this is the angle of refraction. So for this refraction, angle of incidence, angle of refraction, and for this refraction, it is angle of incidence, angle of refraction. This angle remains same. This angle remains same. This angle is called as angle of incidence. This angle is called as angle of emergence. Emergent ray, incident ray, refracted ray. And let us make, or what is that? Let us draw a perpendicular line to this line from this point. From this point, a straight line or perpendicular line to this line. This is angle 90 degree drawing. This line is called as lateral shift. And this normal is extended at this point till this interface. It becomes a right angle for this. Yeah, right angle at this point. With these drawings, we get two triangles. The triangles are right angle triangles. The right angle triangles. Let us name this point as A, this point as C, this point as D, this point as B. So we have two right angle triangles. This is right angle triangle A, C, D, and this is a right angle. This is a right angle means this is the upper is hypotenuse. This is hypotenuse of the triangle. And in this right angle, this is a right angle. In this triangle, this is right angle. This must be the hypotenuse of the triangle. So this AC is common hypotenuse for both right angle triangles because their angles here 90 degree, 90 degree. And this angle is called as R. This angle is known as I minus R. This total angle is I and minus this is I minus R. Because this would be the straight line. If there was no glass slab kept over here. So it has become this line because of the glass slab. So angle changes. I reduces to R. Remaining is I minus R. To this angles, let us apply cos to this angle and apply sine to this angle and see what we get. Then compare the equations. Finally, we get the equation for lateral shift. Let's go for this. Right angle and triangle, I call this as angle of incidence, angle of emergence. These two are same. And R is angle of refraction. Lateral shift is a distance of separation. This length of line is called lateral shift. And this length of line is called as thickness of glass. And the CD is drawn perpendicular. And with this triangle, in this triangle, let us apply cos of this angle. As you know, cos is adjacent by hypotenuse. Definition of cos, adjacent by hypotenuse. In this right angle triangle, this is the adjacent side, this is the opposite side, hypotenuse. AB by AC. See, AB, as I said, thickness of the glass, T symbolizes as T. SL is the lateral shift symbol. T by C. T by AC. AC equals T by cos R equation. Let us call this as equation 1. From this triangle we get it. Now let us consider this triangle, a right angle triangle. Apply sine of this angle and see what we get. Sine means, definition of sine is opposite by hypotenuse. In this right angle triangle, this is opposite side and this is right angle, no, this is the hypotenuse. Opposite by hypotenuse. DC by AC. What is DC? Write the symbol DC, SL, lateral shift. SL by AC equals this. Now let us call this as equation 2. And compare these two equations, equation 1 and equation 2. Left hand sides are same. Right hand side must be equal. This right hand side equals this right hand side. We get this equation. And SL, rewrite this equation as SL equals cross multiply this into this divided by this. So finally, what is that? Expression for the lateral shift. Mathematical expression for the lateral shift. T into sine of phi minus r divided by cos r. For that, derivation of the expression for lateral shift. That is the length of this line. The length of this line depends on two important factors. That is thickness of the glass and angle of incidence. As thickness increases, the lateral shift increases. That is what I said. As T increases, SL increases. And similarly, as I increases, how does SL increase? So I increase means what is the increase of R? There is a variation of I angle. Suppose the object is this, and this is a lever here, lever in this direction. The lever can change the angle of view. Here angle of view is changed. The lever is the angle of view. You can change in this direction. 0 here, increase angle of view. The object is here increase. As the angle of view increases, angle of incidence increases. Look at that. Lever is here, angle of incidence increases. So angle of incidence increases as a result of angle of view increasing from here to here. Object remains same, position remains same. Only this we can change. If this changes, SL changes. How does in this function? As you know, as I increases, R also increases proportionately. Diffraction. As I increases, R increases. As I increases, R also increases in proportion. Overall, almost remains constant. This is a sine function, almost constant approximately. What about cos R? As I increases, what about R? R also increases. If R increases, what about cos R? Cos function decreases. That is why I said. In this case, as I increases, R increases. Is a principle of refraction. As R increases, cos R decreases. Cos of the function increase, this cos function decreases value. Since the cos is in denominator, as the value in the denominator decreases, this value increases. This is numerator. SL increases. This way, as I increases, SL increases. As I decreases, SL decreases. The magnitude or length of this line depends on the thickness of the glass as well as the angle of incidence. Direct proportion. This is the equation for one particular value of refractive index. One particular value, that is refractive index of the glass. It also depends on the refractive index of the glass, but the equation what you have derived is only for one particular refractive index. If the refractive index changes, that also changes. Increase in refractive index increases SL as well, but is a function of these two functions only for a particular value of refractive index. Remember, the distance of separation, that is a lateral shift, depends on thickness of the glass and the angle of incidence and refractive index of the glass as well. This is what the expression for lateral shift. Here, the ray is shifted towards right if the object is kept in the rarer medium and passing to the denser medium and weaving in the same medium. Suppose if you reverse it, the object is kept in the denser medium and weaving in the denser medium through rarer medium. What would be the effect? What is that? Remains same but the opposite. This line will be shifted towards, what is that? Shifted sideways towards left. That is, if that is the case, lateral shifting. It is shifting sideways towards right or left, depends on the type of media you have chosen, initial and final and middle. It is known as lateral shift, and expression for this and the importance of this. This is one important for working out problems. Okay? With this we have completed this subject. Thank you very much.